everyone, my name is Arthur Underwood.
I'm Hypnos Jimenez.
I'm Cedar Kiley.
I'm John Hernandez Angeles.
And I'm Jack Morgan.
And this is our group for the Blue Origin Space Project. We hope to achieve lunar mining in the next 10 years through a process that we have created called Process Nix. In this process, we go over the explanation for our next few missions to the moon to support mining materials from the moon and bringing them back to Earth consistently. So for getting to the moon, we are going to want to use a space tether. One of the reasons why is we don't have to bring excess rocket fuel up to the moon to bring our astronauts home safely, as well as it would be cheaper to bring people home, and we can just send astronauts to the moon and immediately send them back without all the logistical nightmares.
As for how we would get the space tether to the moon, it would be sent up using conventional rockets and parts. It would then be assembled on the moon, where the tether and the countermass would then be put into orbit, as well as additional fuel which could be used to maintain the tether's orbit around the moon. The drill would also be sent up in parts using conventional rockets, where it would then be assembled on the moon and used to excavate resources that would then be sent back via the tether.
Now you know how we plan on transporting the mined lunar materials from the moon to the Earth. But you may be asking yourself, well, how do we actually get these resources? Luckily for this part has basically already been figured out for us. The RASAR robot, which stands for Regolith Advanced Surface Systems Operation Robot, an excavator designed by NASA that uses a bucket drum system to find the surface of the moon. RASAR would collect regolith, bring it back to a lander, and process it into fuel and water to sustain the first few missions. Then, over time, we could send more and more RASARs to the point where we could consistently send back large amounts of water, which could be turned into rocket fuel, and helium-3, which could be used for nuclear reactions.
Thank you for listening. We hope you found our project interesting and would consider our process in the future. Thank you.